have. If we look at the ocean distribution, you can see the northern hemisphere has much more land mass than the southern hemisphere. If you remember the whole idea of continentality, and part of that idea is that water takes a long time to heat up and cool down. And that is why in the southern hemisphere, with these land masses are not as large, these temperature swings are not as great. In the northern hemisphere, you have large land masses and they heat up and cool down very quickly. And so when you look at this, again, the key thing to remember here is most of the ocean is really in the southern hemisphere. We are definitely an ocean world, and just a brief definition: ocean, it's a vast body of saline water, or it contains salt. And this salt is runoff from the land masses. And we'll look at this in a little more detail later. 97% of all the Earth's water is held in the ocean. So you talk about fresh water, or water that is used by humans, you're really looking at only 3% of the Earth's water that is really used. And of that 3%, almost 70% is in ice caps and glaciers, which are not readily available. So what you end up looking at is a very small amount that is used by human beings on Earth. Groundwater, water that is underneath the ground, wells and so forth, aquifers and so forth, is about 30% of that 3%. Other, about 0.9%, and surface water is only 0.3%. And of that surface water, almost 90% is found in lakes, 2% in rivers, and 11% in swamps. So as a percent, fresh water does not make up much of the total water that is found on Earth. Here's just a table giving you some numerical values there. You can look at this as you will. We're not going to hold you responsible for memorizing the numbers, other than to remember about only 3% of the Earth's fresh water, or of the Earth's water, is fresh water, and about 70% of that is locked up in the glaciers and the ice caps. Some glacier facts. You can read these on your own, but glacial ice covers about 10 to 11% of all the land. It's interesting to note, if the seas, or if the glaciers melted today, the sea would rise about 230 feet. And it says during the last ice age, when glaciers covered more land area than today, the sea level is about 400 feet lower. And when we looked at the historical geology, when we looked at sandstone, limestone, and shale, those are all due to a rising and a lowering of ocean levels. And it says, kind of interesting, during the last warm spell 125,000 years ago, the seas were about 18 feet higher than they are today. And it gives a little bit on the largest surface area vane glacier in the contiguous United States, which they mean the lower 48, is a glacier up in Washington. The only thing you really know about glaciers, the general types, are continental and alpine or valley. The continental are ice sheets. Think of those of Greenland and Antarctic. And alpine and valley glaciers are those that, as you would expect, are in the mountains. And those are the ones you think classically. Think of the Alaskan ones. We're going to do a lab activity later this week, and we're going to look a little more on the parts of a glacier and how they flow. But suffice it to say, with an alpine or a glacier, glaciers really flow due to gravity pulling that mass of ice and snow down a mountainside. Here's an example of a continental glacier. It's just a large, really think about a large ice sheet. And as we mentioned earlier, Greenland and Antarctica are excellent examples of this. Probably the more classic ones everybody always thinks of, the alpine or valley glaciers. This is one out of Alaska, those that are flowing out of the mountains. If you ever get a chance to get to the Teton mountains in Wyoming, there are some small glaciers still there.
Glaciers are really are ice and snow that last year round. And like I mentioned, on Friday we'll take a look at a little bit more of those, but we're not going to delve a whole lot with these. So that ends today's really brief lecture on our introduction to water.